दोस्तों नमस्कार. In this particular session, in particular lecture, I have covered a standard 12 physics. In standard 12 physics, if you consider a part 1, this is a central board course. The first topic is electrical charge and its polarity. If you go through the theoretical part of this particular chapter, it's a quite lengthy in the session, but to make it more interesting and simplified, I have attached a simplified pictorial. So let me try to explain the physics standard 12 chapter 1 is electric charge and its polarity. In this particular discussion we will try to understand what is the electrical charge and what is the definition of the polarity. In addition to this we will try to understand what is a static charge, what is an electron, and from the electron the name electricity is been derived by a Greek scientist Mr. Thales, and followed by many definition, positive charge, negative charge. So let me try to explain the electrical charge and its polarity. We will go slow by slow. What is an electrical charge? What is electric charge? So in winter you are supposed to wear a sweater, a silk contained sweaters. And if you remove these particular sweaters, and there is a metallic window also, I have mentioned two pictures. Please see it carefully. One person wearing a sweater, silk sweaters, and there is a metallic window which is at the grounded portion. When you remove the synthetic clothes, especially in the winter when the air is absolutely dry. Now this person has removed the synthetic clothes and slowly it touches the metallic part. When it touches the metallic part, the person is supposed to get a fantastic spark, and which is been declared as an electrical shock observed by the person. I repeat again, a person wearing a sweater, a synthetic clothes in the winter, removed it, and when it touches the metallic part side by, there is a spark and the person observed an electrical shock. The $1 million question, the big question in our mind, why this has been happen? Point number one. From where the spark is been there, and why the electric person has observed a mild electrical shock. So why this has been happen, and what does it called? What does it call in from the physics definition? The spark observed and the electrical shock is been observed. How can we define in physics mode? So let me try to explain. There are insulating material. I have mentioned a two insulating material, and they rubbed together. Slowly, I rubbed two insulating portion together. When I rubbed it together, when the two insulating material rub together, an electrical charge or discharge is been observed. This is the phenomenon. If you take any two insulating material and rub together, the particular material will be called a charge electrically and then discharge. This is a simple. This is called a static electricity. I repeat again. If you take two insulating material and rub together, as mentioned in the picture, the particular material will gain the electrical charge, and this type of electricity gained by the material is called a static electricity. In our house, what electricity we are being used, a fan, a tube light, is called a conventional electricity, but this is not a conventional, this is a static electricity. So when you rubbed an insulating material, the static electricity is developed. Why this has been observed? Question number one, why the static electricity has been developed? It is because of the electrons jumping from one material to other material, one portion to other portion. And this electron is been discovered by the Thales of Milestone from country Greece in 600 BC. And from the electron, the name electricity is been derived. This is the simplified, this is the why electricity, from where electricity is been derived, the name electron, and electron is been discovered by Thales of Milestone from the country Greece in 600 BC. So this is a transfer of electron between these two material, and that is why static electricity is been observed. Now if you after the rubbing, if you hold this particular material, and if you there is a pin, and then the ball, and then there is a paper, This, if you keep this all this material nearer to this particular charged element, it will attract all these three elements. This is called a static electricity power. Many pair of electrical attract towards a charged material, and this is called a static charge. First we understood the electron static electricity. From the electron, electricity is been derived uh, in 600 BC. A scientist from the Greece. The word electricity has been derived from the electron, and this charged particle will attract many materials like a paper ball and a pin also. So this is how the static electricity is been derived. Now the second type, from where you will observe the static electricity. You take a piece of paper and press it. We take a one piece of paper and we press it with the iron. Now we are pressing this particular paper. Once you press the particular paper, this particular paper will get charged. This paper is being pressed by an iron, and now this paper is being charged. Take this paper nearer to the TV screen. Take this paper nearer to the TV screen or any computer monitor. Now let me take this particular paper to particular TV screen, and this particular TV screen, this paper and TV screen, this will attract, this particular paper will be attracted by the TV screen because of the charge, and later on after a few seconds the paper will fall down. This is a second way of static electricity where we can observe in our own house. I will repeat again. Take a piece of paper, press it with an iron, the paper will be charged. Take this particular paper nearer to the television screen or a computer monitor. This particular paper will be attracted by the monitor because of the static charge, and after the few seconds, depends on the how much charge it holds, this particular paper will fall down. This is the second classical example of static electricity. Now the third example is, take two glass rods. I have mentioned glass rods. We will take two glass rods and it will be rubbed with a silk, a type of fabrics. And if we rubbed with a silk, you can see here the rubbing with a silk with a glass rod. This rubbing is continue, and once you rubbed it, this particular glass rod will be charged. Now I take a second glass rod and rub again with a silk. This particular glass rod also, this particular glass rod also will be charged. Depends on the characteristic. This glass rod will hold a positive charge as I mentioned. Now if I keep this both nearer, now the both glass rod are being charged with a positive polarity. I will explain what is polarity. Now if you keep this both nearer, I have keep both nearer, what will happen? Let me try to see with some practicals. I keep both rods with the same polarity with each other, and now both will repel. It will go away from their own position. Again I keep nearer, again they will go. That means if you keep the both glass rod nearer, rubbed with a silk cotton, positively charged, and if I keep both nearer, it will repel with each other. This is the beautiful example of a static electricity. That means the similar charged material repel with each other. And the same story, when I rub the silk with a glass rod, the silk will be negatively charged, and if I keep this silk together nearer, the silk will be repel again. That means the similar charge will repel with each other. This is the classical example of a static electricity. Similar charge will repel with each other. Glass rod as well as this. Now, point number 4. This is the glass rod. If I keep glass rod and silk with in front of each other, please listen carefully. The glass rod is one type of charge, in our case positively charged. The silk cotton is a negatively charged. If I keep these both are nearer, they will attract to each other. Now you can see that this similar charge will attract to each other. The similar charge will repel, but the dissimilar charge will attract to each other. This is the classical example, and the students should remember a similar charge will repel, dissimilar charge will attract. Now moving further, there is a glass rod, sorry, there is a plastic rod, what I have mentioned on the bottom corner, and you can see here there is a cat, and cat fur is there. The small hair, the small hair on the cat is called a cat fur. Now there is a cat fur and a plastic rod. If you rub this plastic rod with the cat fur, the same type of phenomenon you will observe. So this is for the additional knowledge. A glass and silk, a plastic rod and cat fur have a same observation. Now let me try to explain further in depth. These are the two classical examples of static electricity. Similar polarity will repel, dissimilar polarity will attract. Now I have a glass rod and rubbed with the cat fur. एक मेरे पास एक glass rod है. I have a glass rod. It has been rubbed with the cat fur. Now I will attach a two ball. I will put one string. This is a string, and then I attach the two uh, pit ball. This is the pit ball 1. This is the pit ball 2. Now uh, the cat fur is rubbed with the rod, and now you can see once you rubbed with the this particular charge from the rod will transfer to the pit ball. From the rod the charge is transferred to the pit ball, and now the pit ball have a similar polarity. In this plastic, when you rub the plastic with the cat fur, this generate a negative charge. Both the negative charge will be transferred to the pith ball, and both are having a similar charge. This pith ball will repel with each other. You can see here they will try to go away from each other because the plastic rub with the cat fur generates a negative charge, and that negative charge transferred to the pith ball through the string, and now the both balls are being negatively charged and they will repel with each other. Point number 5, I take a glass rod rubbed with the silk. In the last slide, we understood when we rub the glass rod with the silk, it's supposed to generate some positive charge. A string and a two pith ball, same type of pith ball I have been taken. And once you connect one with a string, the positive charge on a glass rod will be transferred, will be charged to the pith ball. Now both the pith ball are being charged positively. But in this case also, the polarity is same, and that is why both the pith ball will be repel at same what we have see in case of plastic rod with the fur pith ball. In both cases, the polarity are same, negative, negative, positive, positive, and that is why the pith ball will not attract but repel with each other. Now the third case on the bottom, I will take a rod and then there is a string. I connect one pith ball of a negative charge. Let me, this pith ball I have transferred to the negative charge, consists of negative charge, and the second side I kept a pith ball of a positive charge. Now these are a dissimilar polarity, and having the dissimilar polarity, now this both pith ball will attract to each other. You can see very well. Now they come closer, closer, closer. So because both have a dissimilar polarity, the ball will attract to each other, come closer and closer. In upper case, on the top side case, both have a similar polarity, so they are been repel. This is the beautiful example with a polar. Now, what we understood. Pitfall rods are being declared electrified, called electrically charged. Once we connect a pitfall with a rod through a string, the pitfall are being electrified. That is called the pitfall got electrical power, and this is electrically charged. Like charge repel each other, and unlike charge attract with each other. This is what we have understood, and that is why this is called polarity of the charges. Once it attract, that means both element have a different charges. Once they repel, that means both have similar charges, and that is called a polarity. Now I have mentioned a two particular material, and then you can see here after the few seconds they both are attracted, and after a few seconds there is a dissimilar polarity, they attract each other, and after the few seconds they will be neutralized automatically. Please listen carefully. I have a two glass rod, one is positive, one is negative, dissimilar polarity. They attract with each other, and after few seconds both are being neutralized. The charge name called positive charge and the negative charge are being given by an American scientist, Mr. Benjamin Franklin. Repeat again. The name positive charge and negative charge, the name were been given by a known American scientist, Mr. Benjamin Franklin. This is how the polarity are being defined. Any element when it does not consist a positive or negative charge, or it will not consist any type of charge, is called a neutral in behavior, and that is why it is called a neutral charge. Element consist of negative charge, elements consist of positive charge, but atoms naturally are remains in a neutral charge. It does not consist any charge. So these are the few definitions for the student. Now the gold leaf electroscope. Gold leaf electroscope. There is a square box, and in the center there is a rod. At the end of the glass rod I have connected one gold leaf in a V shape, what I have mentioned. Now I take a box, repeat again, I take a box. In the center there is a glass rod. On the top of the glass rod there is a ball arrangement. On the bottom side I have connected one gold leaf. This is the gold leaf what I have mentioned. And if I keep one charged rod nearer to this particular, I have keep one charged rod, charged object nearer to this particular box rod. You can see here this particular charge will transfer the this particular charge slowly transfer to the gold leaf. Now both the leaf has an equal charge called positive, and that is why both the end of the gold leaf, please listen carefully, I have taken a box, kept one rod. At the end of the rod I attached one gold leaf. If I keep one charged particle nearer to this particular box rod, the positive charge particle transfer to the gold leaf, and the extreme end of the gold leaf have a similar charge called positive in this case. Now both the end of the gold leaf are now positive, so they will repel with each other. You can see here now both the leaf will go away from each other, and this distance, the distance between the two extreme end of the leaf, what I have mentioned in the screen, is called a quantum of charge. Students, please listen carefully. The leaf extreme end are at the same polarity, and the leaf are separated. The distance is depends on the distance. The degree of expansion of the leaf is called amount of charge. The degree of expansion of leaf is called amount of charge. The similar exercise students can do with a glass bottle also. Same type of behavior, and at the end of the glass you can attach one aluminum foil, and by the same exercise you can see the aluminum foil also can be repelled at the edge. This is for the students. The same practical can be done with an aluminum foil strip with a glass bottle, and once you charge it, the aluminum foil will repel, the edge end of the aluminum foil will repel with each other. This is called a gold leaf electroscope. By use of a gold leaf electroscope, one can judge, one can measure, one can estimate the amount of charge what is been transferred to the gold leaf. The distance between the extreme end of the gold leaf is depends on the amount of charge transferred. So this is called gold leaf electroscope. Now at the end, last practical, I take one piece of paper and press it. What we did in a second slide. We press the paper and then we hold such that the pressed part will remain inner side. The dark blue side indicate the folding is like that. The pressed part will remain inside. Now, if you keep this particular like this one, this is having a similar charge. This particular paper will try to expand from this particular edge. You can see here this particular paper will try the both the end just like a gold leaf. They will try to repel each other and it will expand. So expansion of the paper is depends on how much charge it is been gathered on the paper when you press with the iron. So this is a third example of a static charge. This is the paper will repel. So this is the third example. What we have learned, according to the structure of an atom, there are many atoms. Normally atoms are remain in a neutral in nature. Neutral means there is no positive charge, there is no negative charge, or positive charge is equal to the negative charge, and this is called a neutral in nature. The positive and negative charge are balanced. That means net effect is zero charge. Atoms normally remains in a neutral in nature. If you want to charge any atom, to make it charge, some amount of electric charge need to add or need to remove. If you want to electrify any atom, you need to add some electrical charge or you need to remove some electric charge. Say many atoms consist of electrons. Few atoms can tightly hold their electrons, very difficult to transfer, but many atoms cannot hold their electron and it can be easily transferred from the one body to the another body. Many atoms cannot hold the electrons tightly, and it is very easy to transfer the electron from one body to the another body. When atom donate an electron, most important for the student, when atom donate by an when electron donate by an atom, that is called a deficiency of an electron. This is called a positive charge. But when any atom receive the electron, that is called a negative charge. That means the deficiency of electron observed in the atom is called positively charged. When atom receive the electron, it is called negatively charged. So these are the fantastic definition what we have learned till today. In next topic, we have almost complete 25 minutes. Next, chapter 1 is continue. We will try to understand the difference between conductor and insulator. Thank you. Dhanyawad. This is for the learners. Please take care.